Hi, my name is Turner Bolin. I'm CEO and co-founder of Beagle Learning, and myself and Lindy Elkins-Tanton are going to be talking about open inquiry in online environments. So thank you so much for joining us. We will be talking about roughly three things today. First, why you would want to do open inquiry in an online environment. And then I'm going to be a sort of guide, and Lindy is going to actually be an instructor in a bit of an example course that will show you how exactly she introduces our open inquiry structure to her students at Arizona State University. And then finally, we'll have plenty of time for Q&A at the end. So to kick things off, some brief introductions. Again, my name is Turner Bolin from Beagle Learning, and at Beagle, what I've been working on is figuring out how we can scalably train the 21st century skills that we need for success in the modern world. And so for us, that means communication, critical thinking, problem solving, and possibly most importantly, giving students a sense of agency and self-efficacy in the world so they go out and make an impact. And I will let Lindy introduce herself just like she would to her students in an online class through an example video.
Hi everyone, I am Lindy Elkins-Tanton. I'm the instructor for your class today. I am a professor of planetary science in the School of Earth and Space Exploration at Arizona State University. For the last 10 years or so, we've been thinking about what the education should be for the modern day. We don't think that passive listening in lecture halls is really the best way for people to learn. We think that in the information age where you are inundated with information from all sides at all times, what you need, the skills you need for work and life, are the capacity to solve complex problems or understand complex processes or questions on your own by going through your step-by-step process of trying to understand something big and complicated. You need to learn how to assess information. You need to learn how to have agency for your own learning. And those are the things you're going to learn in this course. In this course, you don't have to have any prior knowledge about any of the topics. We're going to teach you how to approach a complicated topic with your own courage.
All right, so when diving in to open inquiry, one of the first questions might be, why teach using an open inquiry model online? And so I want to show you just a couple articles that we've referenced and results that we've seen that made us really excited to use inquiry more often. So the first one here is from Chi and Wiley in 2014. And what you're looking at is on the vertical axis, the percentage of correct test answers before and after some learning intervention. And then across the bottom are four types of learning. Passive learning, which is a totally standard lecture with no interaction at all. Active, which is lecture or similar things, but students are actively participating via either writing notes or making diagrams or doing problems. And then the final one is interactive, way on the right. That's where students are actually working with other students collaboratively to create the knowledge that they're trying to learn. And what you can see here is that that kind of interactive model shows way, way higher knowledge retention than any of the other models out there. And interactive learning is exactly what open inquiry is. It's exactly the structure we use. So the first reason we use it is just remembering information. It helps people remember information. The second reason, and probably the reason that I care about the most, is that it helps people learn how to learn and practice those metacognitive skills. So here's a quote we love about this. The process of asking questions allows them, meaning students, to articulate their current understanding of a topic and also become more aware of what they do or do not know. And this is very hard to quantify, but two things that we've pulled from our own work and from papers that we've been reading on this. In our own work, we've seen as much as a 50% increase in class attendance during big lecture classes when we add an inquiry component. And then various studies that have tried to quantify problem solving have shown about a 14% increase in problem solving skills when using a scaffolded inquiry approach like what we're doing here. So with that, we think this is really effective. We've seen awesome outcomes, and let's dive in to actually seeing how Lindy would introduce an open inquiry course to her students.
Hi everyone, Lindy Elkins-Tanton here. We have a special way of learning in this class, a special way of solving problems and doing research. Each of you is going to start by selecting a big goal question for the class. This has to be something that has to do with space or space exploration. Some examples from other classes are things like how will humans settle on the moon? Or how will we find life off of this earth? Or what is the universe made of? It has to be something that you are truly interested in knowing the answer to, and you don't have to have any prior experience at all. Now, this is going to be your guiding question for the class, like the class topic, and every student is going to have a different one, your own unique one. And I'm going to have a whole separate video about choosing your big goal question. Now here's what happens once you have your big goal question. Then you start a process we call the question cycle. The first thing you're going to do is find a piece of content that helps you understand something about your big goal question. It might be a journal article to read, it might be an interview, it might be a video, some piece of content that helps you learn something about your big goal question. And then you are going to write a summary of that content. And that summary is going to be a one-page written summary. We've got an assignment that explains exactly how to do that. Once you have summarized the knowledge you've now gained, the next step in the question cycle is to ask your natural next questions. These are the questions that would take you one step closer to learning about your big goal. Whatever questions come to your mind that are pertinent to your big goal and take you one more step. You're going to choose one of those natural next questions. And then you're going to start the question cycle again. You're going to find a new piece of content that helps you to understand this new question. And then you're going to go and summarize that and ask your natural next questions. And that's your question cycle that you're going to do a number of times during this course to make progress toward understanding your big goal question.
All right, so we've just seen this idea of a question cycle, and I'm going to bring that up again now because I want to talk a little bit about how that overlays with a standard semester schedule. So here is that question cycle, and we've added a little bit to it here. You start with defining a goal, and then on the left is that question asking cycle that Lindy was describing. But on the right is this other thing, which is the distillation cycle, where students actually work to distill down everything they've learned into easily communicable chunks of information. And we'll talk about that a bit more later on, but it's important to understand that that's a component of the structure. So in the sort of Arizona State University class that we're talking about here, it's an accelerated 7-week schedule, and this is what it might look like. Week 1's just a couple days generally, so during that we're working with students to define a goal, and then in week 2 students do 2 full question cycles with 1 team discussion at the end to share what they've learned. And then week 7 is dedicated to distillation, where students are distilling everything they've learned and they're sharing that with their team to sort of bring to culmination everything that they have learned. They might also do that sometime in the middle of that 7-week semester if there's time. But you don't have to follow this. This is really flexible to different structures. So here's a 14-week traditional semester structure. It's the same thing except for week 2 through 13 are all single question cycles, and you might add 1 or even 2 more distillations in there. We find that doing a distillation as much as every 3 weeks is really helpful to keep everyone on track. Finally, if you're in an environment where you want a bit more structure or you're going to be doing more work synchronously, you might do something like this, where during those weeks 2 through 13, you actually have 3 different in-person or online synchronous sessions where students are forming questions together, they're finding and summarizing information together, and they're also doing that team discussion and question share. And we've found this is really interesting and helpful, especially in lower grades, 6th and 9th grade classes that we've been running more recently. So with that in mind, that structure in mind, the next bit that we need to address is how to help students sort of scaffold their experience, because we're teaching process here, not just content. So we do need to give them a good sense of how to actually go about tackling these different new skills like goal setting that they may not have had to do before. So with that, I'm going to turn it back over to Lindy to give an example of how she talks to students about setting a goal so that you can get a sense of the kinds of structures we give them.
Hi everyone, Lindy here again. This is your very first assignment in your class. The assignment is to create your big goal question. This is the question that you are going to search after understanding for the entire semester. It's really your class topic, and it has to have something to do with space or space exploration. It has to be something that you are really interested in. You don't have to know anything about it. While you're thinking about your big goal question, which you will check with me and we'll iterate reiterate and discuss, I want you to mainly think about scale. Scale is how big and complicated and difficult a question is this to answer. Imagine that we had a way to rank the scale of questions from 1 to 5, where 1 is the simplest and 5 is the most complicated, most difficult, the question that will take the longest to answer. So for your big goal question, you're going to aim at a 5. That's what you want. So let's talk about 1, 3, and 5. So 1 is just a really simple question, something you could just Google and know the answer. So an example of a question at 1 might be, what kind of star is our sun? Is our sun? Now, you may not know the way an astronomer would answer this question right now, but if you Googled it, you would know in 10 minutes. That is way too small a question for your big goal question. A scale 3 question might be the kind of question you're going to ask every time you go through your question cycle, something you could learn a goodly amount about by reading one really good paper or doing a half week's worth of research. And so a scale 3 question about stars might be something like, what are all the kinds of stars that exist in the universe? That would take a bit of reading, a bit of research to understand, but you'd be finished with it soon enough. It's a good one assignment kind of question. Now, what about a really big goal question that would be in this kind of line of questioning, but really of a scale that would keep you engaged all semester? Well, the example I thought of is, what relationship does the star have to whether life can arise and persist? And so that is a really big question. What relationship does the star have to how life can arise and persist? And let me just talk about this question for a moment to make it more clear what I'm thinking about and why it's a big question. I'm imagining that there's a star like our sun, and around it are orbiting a series of planets. Somewhere on these planets there's life. Maybe it's here, like on the Earth. Well, this star is sending the power out into the solar system through these planets that gives the energy to the surface and the weather and gives the heat to the surface so that water can stay liquid and life can persist or life could arise. And so here's the question: what is the relationship between the star and the ability for one of these planets to have life arise on it and then stay alive? And it's a complicated question, first of all, because no one knows the whole answer yet, so you're going to get to the edge of what humans know. And also because it has to do with both heat and radiation and also composition and age and many, many things that I don't know about yet and that it would take many, many weeks of research to learn. So this is the kind of question that you want to think of for your big goal question.
So that is producing a big goal question and how we try to give students a little bit of structure there. We do also have structure for writing summaries. We talk about finding primary sources, and we're very happy to share all those examples with you. We just don't have time right now today. The other big thing we do want to go through right now is how you get from these individual exercises to a distillation of understanding. We've found that if you just go through the question cycle over and over, it's a lot of fun. People get really excited about their bit of learning and what they can share with the team, but everyone kind of goes down their own rabbit hole, and that is not always the best for feeling like you have reached a good conclusion at the end of the class. So we do a couple things to improve that. And the first one is we use mind maps. So we have students map out their learning in a mind map and then rearrange that mind map to better reflect how they see the knowledge they're gaining fitting together. And so Lindy talks a bit about this at the beginning of her course to help people understand how you might restructure a mind map and use that to guide your own learning. So with that, we'll let her introduce mind maps.
Now here's an example from a previous piece of software of a map that's not been rearranged. It just reads left to right in chronological order. But here's one that has been arranged. You can see multiple questions coming off of content, multiple pieces of content coming off of questions, really trying to organize it as the person has learned the material. Here's another similar example showing two main branches of inquiry that this person has gone through to try to understand their big goal question. And finally, here's one with content hanging off of questions, lots of content and answer of each question. So try to arrange your map so that it shows how you've learned.
So that's mind maps. And importantly, in addition to mind maps, we do two other things to help solidify what's being learned. One are those group discussions, and we do have a standard structure for group discussions where we have students actually rate each other's questions with something called a question productivity index and give each other feedback on their next steps in research to help them find a good direction and tweak what they're learning. The other thing we do are distillations, and a distillation is a moment for students to take everything they've learned and everything they've put in their mind map and distill it down into a simple, easily communicated infographic of some sort. And sometimes that just is the mind map, but we often have some other really exciting things that come out of that. So I want to show you a couple examples. These are from in-person classes that we've taught in the past. And in this first one, you're seeing a group of learners work together at a board to actually create a graphic that is a cross-section of a planet to talk about how planets form and differentiate. And they're taking everything that they know in their class, that they've learned in their class, and putting this on the board. And they do this completely without notes because everything that they've learned is so ingrained, really, because it's based on their own questions. The other way that this can be done is as a full class distillation. So here is an example of a bunch of students at the board all working together to add their own bits of information to a big growing graphic of what all of them have brought to the table over the course of the semester. And we find that doing this helps people sort of recenter on what their goal is and make sure that they're still moving in that correct direction. So this process, I know we've only outlined it in sort of the highest level, but this process works extremely well all online. We found that students are extremely engaged, very excited to participate. It's not pulling teeth to get them to come into the discussions and share what they're thinking about learning next. And we think there's a couple reasons for that. One of which is that everyone is uniquely contributing. They really have something to bring to the table when they come to those discussions, and they feel that, and everyone values those contributions because the person across, well, I guess in this case, across the Zoom meeting also is giving you something unique and helpful. We would love to share more information and more examples from Arizona State University and from Beagle Learning. Please do reach out if you could use any of the resources we've mentioned. And finally, we want to leave you with one last thought. We have been working on taking this inquiry online model and turning it into a program that we're calling Make It Matter. So Make It Matter uses inquiry learning and combines it with a social action project of the student's own choice to actually bring people from identifying a challenge in their community to taking action to solve it. And we split that up into 4 steps. The first is selecting your goal, then doing that background research using the inquiry cycle we've walked through today, planning an action, taking the action, and then paying it forward, or really reflecting on what you've learned and documenting that for future groups. So we're just launching this. We're running pilots around the US of the Make It Matter program this year. We're really excited about this. So if this is also an area of interest for you, please do reach out. We'd love to help you kick off your own program.